Hi, Peter Dorman again. The topic now is elasticities. In particular, what we'll talk about is what's an elasticity in general? What's the topic of what is an elasticity? And in particular, what kinds of elasticities are there? There's almost an infinite number of them, but there are a few that are of particular interest in economics. We'll spend most of our time talking about how they're used, and at the end, I'll have a few words to say about why it all matters. So it's a bit forbidding to look at the formula for, the general formula for an elasticity. You see it algebraically on the bottom. It's the percent change in some x divided by the percent change in some y. And the way that translates verbally is it's the percent change in x in response to the percent change in y. So you can think of x as being something which is affected by a y. So it might be how much you buy, which is affected by the price, or it might be how much you buy, which is affected by your income, or it could be something else out there in the world, which we're not going to be talking about today, where one thing depends on another, and the elasticity formula is what percentage change that you have in the thing that's affected relative to how much percentage change you have in the thing that's doing the affecting. So that's the general notion of elasticity, but it will probably become clearer when we talk about particular elasticities. So take the elasticity of demand. The formula for this is, in the numerator, it's the percent change in the quantity demanded, in the denominator, the percent change in the market price. So the x here is the quantity demanded, which we assume is affected by the price that people have to pay for stuff. Normally, we expect this to be a negative number. And the reason for that, of course, is that if the price of something goes up, you typically buy less of it. Or if the price goes down, you buy more. It's an inverse relationship. So if the numerator is going in one direction and the denominator in another, you get a negative number. We divide the world up into elastic and inelastic goods. So elastic goods are goods where the percentage change is greater in the numerator than it is in the denominator. So quantities are fluctuating quite a bit relative to prices. An inelastic good is one where the change in the numerator is less than the change in the denominator. So the prices are moving a lot, but not so much the quantities. One way to think of that, if you want a mnemonic device, is imagine like a rubber band, which is elastic. A really elastic rubber band can be stretched, whereas an inelastic rubber band, you pull on it and it doesn't stretch very much. Well, think of this as the stretchability of consumer demand. If you're changing the prices, does consumer demand stretch a lot, or does it remain relatively fixed? If it stretches a lot, then the demand is elastic. If you go online or into the economics literature, you will find hundreds of estimates of elasticities, price elasticity of demand, for a variety of different things that people buy. And I'll talk a little bit more later about how those estimates are constructed. But for now, just assume that you look up the estimate and you find it there somewhere, and so that tells you what the elasticity is. Let's go through a sample problem. Let's consider, for instance, dinners at a campus dining facility. So suppose that the elasticity is minus 0.5, so that the numerator divided by the denominator of that formula is going to give you a minus 0.5. That's inelastic, right? Imagine also that the initial price is $10 a meal, and the campus authorities are thinking, what will happen if we raise the price up to $12? Will we make more money or less money? What kind of a drop-off in demand will there be for these meals? So suppose, third little input here to the problem, suppose that the initial demand is 500 meals a night. 500 students show up to buy the $10 meals, and you're thinking, well, if I know the elasticity, okay, the price elasticity of demand, and if I know the price increase that I want to introduce, in this case from $10 to $12, I can use that to predict what's going to happen with the number of meals that students will purchase. So take a moment here to pause this video, pull out a pencil and paper, and try to work out this problem, and then come back and I'll work it out for you. So now I'm back, and here's how it works. Our formula is equal to minus 0.5. We were given that information. The change in price is from $10 to $12, so that's a 20% increase in the price. That is, it's a $2 price increase divided by an initial price of $10. That's a 20% or 0.2 increase in the price. So we have the denominator of the formula, the percentage change in price, and we have the right side of that equation, which is the value of the whole elasticity. It's minus 0.5. So now we have to solve for the numerator, the percentage change in the quantity demanded. To do that, we multiply both sides of that equation by 0.2. And so 0.2 will cancel out on the left side. And on the right side, we get minus 0.5 times 0.2, and that equals 0.1, or minus 0.1 rather, which is a 10% drop-off that you expect in the number of meals demanded. Since the initial number of meals was 500, a 10% drop-off should lead to 450 meals. This is something you should be able to do. Now let's look at before we move ahead, I would like to say that this is, as I mentioned before, an inelastic demand, and the main determinant of elasticity is the availability of substitutes. So if you can imagine students at an urban campus where they can just leave campus and go to any restaurant on the college strip and get another meal, you would expect the elasticity to be quite substantial, the stretchability of student demand, so that if you raise the price on campus, students will leave campus and get something else. On the other hand, you could have a college like Evergreen, which is, has no restaurant close by, and it's more of a hassle for students to go out. And in that case, you would expect an inelastic demand, which increases the ability of the meal service to charge higher prices. Availability of substitutes is the primary determinant of the elasticity of demand. Now let's look at a different elasticity, the income elasticity of demand. This is a pretty important one for a lot of purposes, especially businesses employ economists to figure this out. Here, the numerator is still the percentage change in the quantity demanded, but the denominator is now how much money the consumers have, or the percentage change in their income. So it's often the case that we're interested in the effect that either economic growth or recession or something like this will have on the demand for particular products. That's why we use an income elasticity of demand. For most goods, this is a positive number. That is, if your income goes up, typically you buy more of it. We call those goods, quote unquote, normal goods. But not every good is a normal good. There are some goods where if your income goes up, you actually buy less of it. Those things are typically at the bottom end of the consumer market, where people move out of those markets if their income rises. In general, necessities are goods that have lower elasticities, because people buy them whether their income goes up or down. They feel they need to buy these things, so the demand doesn't change that much with income. Luxuries are things that people buy when they have the income. They don't buy if they don't, and so luxuries would typically have a higher income elasticity of demand. So let's look at a problem, sample problem. For instance, pickup trucks. People out there buy pickup trucks. Suppose that we know the income elasticity of demand. It's 0.8. And suppose that we're forecasting over a period of time in which the average income of the consumer population will go up from $50,000 to $60,000. At the beginning of this period, 1 million trucks were being sold, say in a year. So now we've been asked by some company or somebody to figure out how many trucks we think are going to be demanded after income rises. Again, you should pause this video, pull out a piece of paper, and try to solve the problem on your own. And then I'm going to solve it as I would solve it. So let's look at the solution. In the solution, the formula for, again, is 0.8. So that's the income elasticity of demand. The percentage change in income is from 50 to 60. That's 10,000 divided by 50,000. So that's 20% or 0.2. We now have the denominator of the fraction. We are trying to get the numerator. So we multiply both sides by the denominator, 0.2. It cancels out on the left side, and on the right side we get 0.16. That's 0.8 times 0.2. And that's therefore the change in the quantity demanded. We started with 1 million. If you increase by 16%, you get 160,000 trucks. And that's the answer to the problem. Now finally, one more elasticity, the elasticity of supply. In this case, the numerator is now the supply side of the market, the percentage change in the amount supplied to the market. The denominator is the price that sellers will get for this good. We know that some goods are very elastic. The supply increases substantially if sellers can get a higher price. Over time, that is over longer than a growing season, agricultural commodities are like this. So if the price of soybeans rises, farmers will plant more soybeans, and when the next harvest comes, there'll be a lot more soybeans on the market. Similarly, if the price goes down, then people switch from soybeans to something else, and next year there are fewer soybeans. So that's how it tends to work for agricultural commodities. Other goods, on the other hand, are in relatively fixed supply. A classic example is tickets at a stadium, where the stadium over a long period of time might be expanded, or you could even tear down the stadium and build a new one. But over the time period that you're interested in, usually the number of seats in the stadium is relatively fixed. And if there's a big concert there or something and it's sold out, you're not going to just magically create more seats because the price of a ticket has gone up. So it's a fairly fixed supply or an inelastic supply of seats in a stadium. In general, the elasticity of supply depends on the availability of inputs. So as long as land for growing agricultural commodities is relatively abundant, you would expect to see a very elastic supply of those things. On the other hand, the supply of seats to a stadium, which is what allows you to sell tickets, is pretty fixed in the short to medium run, and so that's going to be inelastic. Here's a problem. So we're going to start again with the formula, and let's suppose that the elasticity of supply, we're talking about meals at a restaurant now. Now we're not talking about campus dining service, but at a restaurant downtown. Suppose the elasticity of supply is 0.1. That's pretty inelastic, which actually makes sense because in the short term, it's difficult for a restaurant to vastly increase the number of meals it offers due to lack of seating and kitchen size and things like that. So suppose that they're initially serving 800 meals a night. I guess that's quite a lot, but suppose that's the number. And suppose that the price that they are proposing to charge, or the price that they can charge, goes up from $40 to $50 for a meal. What do you suppose the new supply will be? Here we're going to solve it. It's the same procedure as before. We have the elasticity, it's 0.1. We have the denominator, it's 50 minus 40 over 40, that's 25%. So we multiply 0.25 times both sides, and it cancels out on the left, and on the right, we have 0.1 times 0.25, that's 0.025. So that's the additional number of meals that will be supplied at the higher price. So we have the 800 plus the additional 20, is 820 meals. So there you have it. The final point I would like to make about elasticity is that there's a very important elasticity which we'll come back to in a subsequent lecture, the elasticity of substitution. Typically, the average person out there doesn't care about this. It's a fairly technical elasticity. It's basically looking at the change in the market equilibrium for a particular good, change in either production or consumption, but looking at two goods simultaneously, so comparatively. So you're looking at ratios of two goods, A and B, in the numerator for quantities, and you're looking at ratios of two goods in the denominator for prices. So it's the percent change in the ratio of A to B, the quantities, in response to a percent change in the price ratio of A to B. What's interesting about this is that it enables you to, by comparing different goods, if you were to do that for all the goods in the economy, you would be able to calculate the entire change in the whole market system, not just one market, but the entire market system for small changes in relative prices. I mentioned small changes because elasticities, as we'll see, are really just about relatively small changes for reasons the next lecture we'll get into.